All right, everybody, thank you for joining us for Community Day. This is an exciting time, and first and foremost, I'd like to thank the organizers of the event. As you can imagine, countless hours goes into planning this, and with the switch to a virtual conference, that's thrown everybody quite a monkey wrench. So next, I just wanted to go a little bit through what this process is going to be like. By now, you should have the Slack channel up. That's a great place to know where you should be and ask any questions of the group. The way this is organized is there are two Zoom channels. There is track 1 and track 2. If you're here on the keynote and you want to attend a track 1 session, you'll just remain on this URL in this Zoom track. And if you want to attend something in track 2, then you'll simply get off of this channel and go on to the next one. And talk a little bit about our schedule here. So this is also available on the website, but our first speaker will be Randall Hunt. And then from there, we will break into our tracks of 1 and 2. Sorry to go back here. The URL is now live, so midwestcommunityday.com/live, and that will give you all the links to the Slack channel, to the various tracks, and to the schedule. So that's a good thing to have a tab open so you can know what's going on all day. We want to thank our gold sponsors. Without you, this absolutely cannot be possible. So thank you to AWS, Trend Micro, and New Relic. We really appreciate the donations that you've made to make this possible. As I said, you can imagine there are licensing and all sorts of things that we didn't plan on. So we're very pleased to be able to bring this to you today. So for our keynote, I would like to introduce Randall Hunt. Randall Hunt is a software engineer and developer advocate at AWS. He currently works with the Amazon Connect team to build solutions for customers, launching next generation contact centers. Obviously, he traveled the world meeting customers, building solutions, and speaking at events. Prior to working at AWS, Randall launched rockets at NASA, SpaceX. I don't know about anyone else, but I have a huge nerd admiration there. But he found his programming passion at MongoDB. He's a total nerd. You could reach Randall anytime on Twitter. So you guys might want to have Twitter open. We'll be sure to share those Twitter handles where we can. He's at JR Hunt, which is JRHUNT, or you could reach him by email at randhunt@amazon.com. That's RANDHUNT@amazon.com. So if you could all give me just a moment here, we've got a little wrangling we need to do on the back end, and we will be starting our keynote shortly. And we're hoping to get all of our technical difficulties out of the way here early. We are waiting on Randall at the moment. He's an LA guy, so as you can imagine, this is kind of an early morning for him. So if we could just have your patience a little while longer, he'll be with us here shortly. In the meantime, if you guys have questions, throw those into the chat and also in the Slack channel. Thank you. I do want to take a moment too to talk about the happy hour. This was kind of a late addition. So we are using a unique platform called Remo. If you're not familiar with it, the best way to think about it is if you would go to a wedding reception and you're assigned to a table, you're actually able to move 2 tables over and talk to Uncle Joe. So this is actually a similar setup. So when you come into Remo, you'll just get thrown to a table and it'll spin up a video chat for each round table. You'll be able to mix and mingle with your fellow attendees. It's a shame we can't do this in person, but we wanted to at least give you a chance to spend some time getting to know one another. A few things to note in the Remo UI. In the upper left-hand corner, you'll be able to choose what your audio and visual uh, devices are. So if you're using a headset and not hearing anything, make sure you take a look in there and that you're using the proper headset. You also have a chance to customize your bios. So be able to go in there and throw a headshot in. You can have a link to a Calendly if that's a platform that you use, and also connect to your LinkedIn. So you want to take advantage of those features. We have a few moments here while we're waiting on Randall. So I'm going to go to remo.co. That'll give you a great little overview of the platform so you'll be familiar, but we sincerely hope you will join it at that time. In the meantime, again, thank you for your patience, and we will get started here shortly. I see we've got people rolling in. Just so you think we're not dead air on purpose here, we're just waiting on Randall. He's going to be with us in just a couple of moments, so appreciate your patience. Just a reminder, if you're just joining, there are 2 tracks. So the way this is working, we have Zoom URLs set up. So if there's a track that you want to be in track 1, you are already there, so you don't need to do anything. For track 2, you just simply close out this Zoom meeting and join the other webinar. So if you have questions about the schedule, you could go to, I'll pull this up on the screen again, messcommunityday.com/live. And there you will find the information on the Slack channel, what the schedule is, and how to join each of those chats or tracks, my apologies. We are almost ready to get underway. We're getting it all out in the beginning, so thank you all. Yeah, so I've got a question here. Someone asked, can you jump between tracks? Absolutely. So basically, you know, it would just be like you had two concurrent meetings on your calendar at work. So you just would, you know, say you want to leave the one meeting and then just join the other. So you can feel free to go back and forth. We've got various levels of technical ability and talks with different levels of technical knowledge. So, you know, if you get into one track, find that it's either not technical enough or too technical for you, by all means, just end that meeting for yourself, jump over to the other track, and you know, you should be good to go. One thing I did want to mention here as well, if you're not familiar with the user groups, hopefully you've all, you know, come here as a result of a user groups, but this is the culmination of all the various AWS user groups in the Midwest. So be sure to go and check those out if you're not an active participant. It's a great way to get involved and learn more. The topics are educational, not salesy, so it's really a great asset. So really quickly, some of the user groups represented here are Ann Arbor. Chicago actually has two groups. There's the downtown and then the suburbs. We have Cincinnati, Cleveland, Columbus, Dayton, Detroit, Fort Wayne, Indianapolis, Kansas City, Louisville. I know enough to say that instead of Louisville. Madison, Milwaukee, Minnesota, Pittsburgh, and St. Louis. And if your city is not represented there, of course, we'd love to have you start one. Another question we have is, will the tracks be recorded for viewing offline? Absolutely. Have a little patience there. We do have to parse out each of the talks. So I believe last year that took about a week or two. So absolutely, those will be available. Another question was, are there any last minute changes to these sessions? Outside of this little blip with having a speaker delay, no. The schedule is exactly as you see it on that midwestcommunityday.com/live link. So keep the questions coming, guys. We've got a few minutes here to wait. Actually, I just heard Randall is with us, so I'm going to make him a speaker now, and you don't have to listen to me ramble on. So thanks again for your patience. Hi, Randall. Great to have you here. We already introduced you, so thanks for joining us. We're very anxious to hear your keynote.
Hello, can you hear me?
We sure can, Randall.
Hello. All right. Hello, everybody. I apologize for being just a little bit late. It's a little early here in Los Angeles. Are you able to see my screen? Everything looks good?
Yep. You're ready to go.
All righty. Well, I'm going to jump right into things. So hi, everybody. My name is Randall Hunt. I'm a software engineer at AWS. I wanted to thank the organizers. I wanted to thank the community for taking the time to organize this, for inviting me to speak today. I'm going to try and keep the sales pitch portion of this talk to the absolute minimum. And then I want to focus on the things that I think really, really matter right now. So this is me. I've spent about 15 years writing all sorts of software. I started out in video games, and then I studied physics, and I built a number of different systems for mass properties engineering at NASA. Then I joined MongoDB as a small startup, saw that grow into a very large company. And then I came to SpaceX, and then I came to AWS, and I've been at AWS for around 6 years now. I have really enjoyed my time here. It's a great place to learn and pick up a lot of knowledge. I spend most of my time writing Python. I do a little bit of C++, a little bit of JavaScript. I focus a lot on machine learning and AI, continuous integration, databases, and serverless and containers as well. And that spectrum of compute. Outside of work, love to ski. I love space, and I love making fun of JavaScript because it's the best of things and the worst of things all at the same time. You can find me on Twitter at JRHunt. This is my actual badge photo. They asked me if I wanted to have it changed, and I said, no, it's a pretty good summary of who I am and what I do. So I wanted to say a quick thank you to Chris Fife, Richard Boyd, and Ricardo for their help with these slides. A lot of times I see people presenting decks and presenting slides, and they never really give a shout out to all the different people that work together to help make those slides. So this is a shout out to you guys. Thank you. What I want to talk today about is just some recent updates that are my completely biased and favorite updates. I want to talk about community. It's Community Day. And then I want to talk about something that I really have been convinced in, which is the CDK. So AWS is pretty big now. It's been big for years, but it's getting bigger and bigger all the time. It's about 23 regions. There's 73 availability zones. There's more coming all the time. 216 points of presence, meaning edge locations. It's CloudFront edge locations. It's 205 different edge locations, and then 11 regional edge caches. This is in 84 cities across 42 countries. And in order to build all this and do all of this, we actually rely on the community to tell us where customers are and what they're asking for. So if we zoom in on just one of these, right? Let's take a look at US East 1, for instance. I have no idea if Zoom is going to correctly deal with this animation, but if we look at a single availability zone with a extremely redundant network laid out before it, you can have something like 388 unique fiber paths between each of the data centers in this availability zone. These zones can have up to 300,000 servers. I mean, these things are huge. These are not individual data centers. And I think it's an important and meaningful distinction to understand is when we say availability zone, we're not saying data center. We mean something that has meaningful geographical separation from the other availability zones in that region and can withstand, isolated power events and stuff like that. So in order to enable all of this development and all of this kind of uptick in I said 380 unique fiber paths, but in aggregate, those fiber paths provide something like 5,000 terabits of capacity in a single region. So 5,000 terabits. My wife is an engineer for Boeing, and they work on satellites. And I was amazed to hear that these different satellites, they can deal with, hundreds of terabits of throughput, but 5,000 terabits of capacity in a single region is just mind-blowing to me. And this is just the beginning. I think when you think about 100 gigabit per second networking, that's not the end of our story. And in order to enable these things, we have to innovate at every level of the stack. So with traditional fiber, right, you have a couple different ways of packing things and a couple different ways of making fiber work. You have something like putting more fibers in the same conduit, a conduit meaning like a PVC pipe that is, 3 inches or so, or 2 inches. And then you can do DWDM, which is dense wavelength dimension multiplexing, or you can use other techniques in order to expand that fiber and make it work for longer lengths. But the end all be all is how much fiber, how much capacity can you fit in a single 2-inch conduit, and what does that metro fiber look like? So on the left-hand side, you see the fiber that we used to use in our data centers. That's 3,456 fibers in a single 2-inch conduit. And then on the right side, you see the exact same 2-inch conduit, but now it has 6,912 fiber pairs. And I like this example because it helps to underscore the level of responsibility and the level of innovation that we have at AWS towards investigating and innovating at every level of the stack. So if we were to just, use standard metro fiber, right? Because if you look at these fibers, this is literally, we have a applied photonics lab where we're going and researching how to make fiber optics better. And we share this, with the whole industry. And it's not just us, of course, there are contractors and developers that contribute to this, but this is the kind of innovation that we use to build out every service we work on. And I like this distinction because it's a low level, interesting distinction that we don't always see from the rest of our presentation. So with that said, keep this in mind as I present the rest of the content today. I wanted to start with my completely biased list of recent updates going back to February. So at the top of things is the Builders Library. So I'm a software engineer, I'm a developer. I work right now with the Amazon Connect team. And the Builders Library is a very powerful and interesting set of blogs, content, articles around building resilient systems. Just yesterday, we launched AWS Code Artifact. This is a way to host private Maven, Gradle, NPM, pip, whatever repositories for your code. This lets you keep private packages for your company. Just for some context, this is really, really common in the enterprise to be able to have a mirror for these different things. We launched cross-cluster Amazon Elasticsearch queries, code pipeline, step functions, actions, Amplify, which is something I'll talk about a little bit later, is a set of tools, not just for the UI or for the console. It's a service, a console, and a library all in one. So it's a UI library, and it's also a JavaScript library that has React and Angular and other integrations. And they recently launched or made generally available their iOS and Android toolkits with a set of ML tools as well. And then SAM, which is the serverless application model, adds support for step functions. And then I know I can't hear anyone or see anyone on Zoom, but if anybody wanted to unmute themselves and just celebrate with me the fact that DynamoDB can now deal with empty values, and this is probably my favorite feature that has ever launched in the history of AWS. I've been waiting for this for so many years. And just for context, I was a community member before I was ever an AWS employee. So I 100% understand and empathize with a lot of this community. We have the CDK for Kubernetes. I'll talk a little bit more about that later. Macy got an 80% price reduction. And then Amazon Linux 2 can support live kernel patching. CloudWatch Synthetics, these are basically, a lot of people might know them better as canaries, but what it means is CloudWatch can run a metric or an alarm for your application and check on the status of things at a defined interval. Pinpoint has custom channels now. So Pinpoint is you might be more familiar with marketing terms like segment. It is a tool for dealing with and understanding how your customers are progressing throughout your applications, as well as reaching out to them on the channels that they are interested in receiving. PyTorch is probably my favorite machine learning framework. I don't know if I'm allowed to say that in Amazon. I think I'm supposed to push MXNet, but PR and legal aren't here. So I'm going to go ahead and say, long live PyTorch. PyTorch is my favorite. And TorchServe is a way of serving PyTorch models much more easily within Amazon's infrastructure. It's not a Amazon alone project. It's actually an open source project in conjunction with Facebook. Fargate launched their 1.4 platform. This includes support for 20 gigabyte volumes, for EFS, and then for a couple of additional networking tools. BottleRocket is a containerization kind of runtime written in Rust. There's some really, really great concepts in BottleRocket that I think, this code is open source. It's on GitHub. If you get the chance, just go through it, read some of the different components. It's extremely well documented. It's developed in public, And I am pretty proud of the team that released this, because I think that it shows a commitment to developing in the open and working with the community to build out the best tools available. And then we have Python 3.8 for Lambda at Edge. I love this. Python 3.8 runtimes are significantly faster. You know, I have a couple different functions running in production right now that are executing in, I don't know, 10 milliseconds, as opposed to, you know, the older Python runtimes are going at something like, I don't know, 200 milliseconds just for the init. And these 3.8 functions just instant over and over again. So we also have faster EBS on Nitro instances, which are virtually all of the newer instance types. Okay, so those are my updates. These are my favorites. I apologize to any AWS teams that I might have forgotten to mention, but thanks to all of these great updates. Okay, so what does it mean to be a community? I, like I said, was a community member long before I was a AWS employee. So I started using AWS in 2010 when I was at NASA, and I continued to use it throughout my career. I owe a lot of my career success to AWS. There are things that we would not have been able to build in traditional infrastructure. But I think what really allows AWS to flourish at its core is its community. And you know, I'll be real with everyone for a second here. You know, COVID-19 and recent events have really brought the concept of AWS communities to mind, and maybe not even just AWS communities, but communities in general. We used to think of community, I guess, as our local neighborhood, right? As our immediate friends and family and neighborhoods. We've learned that our communities now have broad effects that spread far beyond our local events. And I think it's important to recognize that and use that power for good. And I don't know all the right answers. I don't know what the right way to do things is, but you know, I'll go on record and say that I don't believe that selling facial recognition software to police and ICE and things like that is the best way to foster a vibrant community for AWS. And I'm proud of recent changes that we've made, but I think that it's a little bit late. I would have preferred to have seen that a lot sooner. And I'm really proud of this community for pushing for those changes. So when we look at what communities are, it's not just, you know, a website. It's not just a meetup. It's not a user group. It is a collection of individuals who are writing and dealing with code and building a culture around that code, around that communication. It's not about happy hours or social hours. It's about people, code, and culture. And I wish I had a better description to share with everyone today, but I'm going to be a community member for AWS long after I leave the company, long after I will keep contributing and working on these things. And it's not because AWS is my only choice in building and developing things, right? It's because this community has a much stronger and more powerful set of things to offer than our, you know, it's more fun than the JavaScript communities, is I guess the way to put it. You know, we all deal with open source. We all see, you know, the way that communities can develop. Let's look at Redis as an example. You know, I'm not going to name names or anything, but they're led by benevolent dictators essentially, and Salvatore or you know, the Redis leaders, whatever personal issues they may have, they rule that code base. And there are certain tools that we're developing now in the open where our communities are really providing the input, and we're doing our best to listen and build those things in the open. And I think that really is a much better and more powerful way of building software and maintaining a positive and opening and empathetic culture. And I realize it's a little wishy-washy. It's not the most defined way of talking about community, but I just wanted to say thanks to all of you, whether you're a community member, whether you are a community participant. The fact that so many of you are here and listening and working on AWS, becoming leaders and telling people about AWS, that is the most inspiring thing for me. It keeps me motivated every morning when I wake up, and it's a little bit early here in LA, so I apologize for being a little bit late today, but I've spoken at virtually every meetup in the United States, and I'm happy to continue doing that. I love meeting all of our users all over the world. But real quick summary, the fact that I've been off the road now with COVID has taken a mental toll on me, because one of the best parts of my job was going and talking to all of you all the time and hearing how you were using AWS. That was super inspiring. And I did my absolute best to take all of that information and provide it to the service teams and have them iterate and build on new things. And I've been so inspired by the way the communities have come together to make these virtual events. So that's really, really cool. So what can we do more, right? Because communities drive code, which drives the culture, or communities drive culture, which drives the code. It's this kind of Venn diagram of things that happen. And I think if we take a step back, what I'd like for us to focus on is becoming leaders. I believe in using boring technology. If you want to write stuff in PHP, and Michael Musa will probably make fun of me for this later, but go for it. I don't think you need to use the latest and greatest thing unless the latest and greatest thing is enabling your company and allowing you to provide differentiated business value. But as community leaders, as community participants, you have a modest responsibility to go out and learn about the latest and greatest, and then occasionally drag those around you kicking and screaming into the future. So I wanted to use CDK as an example of that. So just for context, I was one of CDK's biggest detractors. If you go and look at my tweets from 2017, 2018, I said, we already have CloudFormation. Why do we need this CDK thing? CDK is the cloud development kit. And I'm just going to go on record right now to say that I was completely wrong. Okay. I had no idea how great this was going to be. So think back to the way that we used to provision infrastructure. This required a purchase order. We would get servers. We would rack the servers. Maybe it was in a colo, maybe it was in a data center, but we would do this work, right? And it was physical labor combined with a set of network mappings and maybe even a peering agreement and some other kinds of things that would happen. What different clouds have enabled us to do is to provision infrastructure over APIs. And those APIs are essentially just programming constructs. And so Cloud Development Kit, I think it used to be called CloudFormation Developer Kit, but CDK, or Cloud Development Kit, is realizing that YAML, I don't know how many of you work in Kubernetes, but YAML is a pretty crappy format for defining our infrastructure. And I don't want to spend all my time writing YAML. It doesn't have autocomplete. I'm an engineer. I want to write code. So I'm kind of thinking that this term of infrastructure as code is maybe outdated. Maybe we should move to infrastructure is code, because as clouds have built these different levels of abstraction over racking and stacking hardware and provisioning servers and provisioning functions and provisioning storage, we have built out a way of treating software as code, or sorry, treating infrastructure as code. And we can develop our infrastructure in the same way that we develop our code. It's just one level of abstraction up. And again, I was a huge detractor of this when it first started. And it was only when I started using this in production and really developing production grade multi-region software that I understood the value of this kind of abstraction. So what is it? What is CDK at its core? CDK at its core is a development framework for CloudFormation. CloudFormation, just in case you're not aware, is a JSON or YAML based config file that can go and provision AWS resources. It's templated infrastructure. And what CloudFormation, what CDK does is it provides a number of abstractions over CloudFormation, but the end output is still a CloudFormation template. It's still, this resource that CloudFormation will consume and build all of your resources from. And what I like about it is it uses a framework called JSII, which can take TypeScript and JavaScript and interpret them into different programming languages. So I can use TypeScript, I can use JavaScript, I can use Java, I can use C#, I can use Python, whatever, to write out my infrastructure. And the best part of this is, whatever IDE I'm using, I can get my normal autocompletes, whether I'm in VS Code or Vim or whatever. I am able to write out and get fuzzy search and autocomplete on all the stuff that I'm building. My infrastructure that is relevant to my code can now live as code alongside my code. And it can be iterated on, it can be continuously integrated and deployed. I can write tests against it. And this is just a game changer. It's a level of abstraction that is going to win. And, I can't share too many crazy statistics or anything with you. But what I will share is that CDK, in my humble opinion, is the future. Like infrastructure as code is kind of dead. Like these YAML config files or JSON config files, I see no reason for these to continue to exist. Our infrastructure is code at this point, and I really believe over the next 2 years that virtually every stack will move to CDK. And of course, there'll be laggards and there'll be things that stick around in CloudFormation, but everything that I've developed over the last year has been built with CDK. Most of our new services and internal software are being built with CDK. And there's such a powerful community and open source timeline and roadmap behind this that I don't see it going away. We've released projects in the past, right? Like, does anybody remember ECS blocks? Like we've had open source projects and initiatives that have failed. And I think that's fine. I think it's fine to experiment and fail. This is not a failure. This is the future. And I don't say those sorts of things often. If you look at my past talks or my past conversations, I normally am pretty sarcastic is not the right word, but I'm normally pretty blunt in my delivery of what I think is good and what I think is bad. I think that CDK is net good, and I think it's going to change the way that we think and develop software. And it would be extremely, extremely important for anyone working with AWS to learn it and understand it. And I'm going to give you an overview of it now, but if we break down CDK, at its core, you have this concept of applications. Applications can have multiple stacks within them. Those stacks obviously have resources. This is very similar to CloudFormation, right? CloudFormation has resources. You can have parameters. You can have all kinds of other things. What separates CDK is the concept of constructs. So constructs break down those underlying resources. Okay, bye. Sorry, my wife is going to work. They break down those underlying resources and provision them for you. And what the constructs do is they apply a set of sensible defaults to those constructs, to those resources. And if you think about the way that you provision CloudFormation resources, you have to be explicit, right? You have to give a lot of detail in the way that you are telling CloudFormation to provision this. Whereas 90% of the time, developers are spinning up the exact same thing. You know, we're all used to this in programming. We have to provide more information than we need in order to get the right provisioning. So I'll talk a little bit more about constructs in a moment. And then the next component is the command line interface, the CDK interface. And this is an extremely powerful way of going out and provisioning that software. What CDK deploy is doing is it's just synthesizing the template, and I'll talk a little bit more about that later, and turning your code into YAML or JSON or whatever, and building all your assets and stuff. So you have your application, you have your stacks, you have your resources. These are your constructs. This is your source code. I mostly use TypeScript for this. You use the CDK CLI to synthesize those constructs into assets and into templates. Then you deploy those templates and assets into CloudFormation. And then CloudFormation is responsible for provisioning those resources. So there are a lot of different things that are going on right now. There's CDK8s, which is CDK for Kubernetes. There's a TerraStack, which is the Terraform kind of version of CDK. There's regular AWS CDK. And there's a little bit of a paradigm shift here, right? So if you think about the way that we traditionally develop solutions, the way we traditionally make parameterized and reusable CloudFormation templates, right? In the past, we have used CloudFormation imports and we have used parameterized templates where we provide arguments to the templates as they're being deployed. This is the biggest change that I find people have trouble with. And this is something that I see people still doing when they're building their CDK builds. They are setting up, I guess, parameters, CloudFormation parameters, instead of making use of the CDK context. So the CDK context is something that you define at the CDK level, which synthesizes multiple templates, right? So if I have multiple regions that I want to deploy to, I don't need to have a CloudFormation parameter as one of the inputs to my template. I just make different templates, and CDK can go and synthesize those templates for me. I can even loop in my code and provision a new template for each one of these regions. Or I can say I want to have, an example I'm working on recently, and this is maybe a little peek into some of our internal infrastructure. I have a set of Lambda functions and Docker containers. The Docker containers are responsible for running long-lived proxy connections to a third-party service and collecting events from that third-party service, and then invoking Lambda functions as those events come in. So that solution is running in multiple regions, of course, because it's an AWS service. It has to, deal with all of this input, thousands and millions of requests per second. And then in order to provision that, if I were to write it in CloudFormation or maybe one of our internal tools, it would be a huge pain in the butt. With CDK, I can write a loop to define the base constructs of each one of those proxy containers or each one of those proxy lambdas or lambda functions, just to make Chris Munns happy. And I don't have to sit there and manually specify everything. One thing I will say is that within CDK, I will often see people, you are prone to over engineering, right? Because it is code. And if you're a Java engineer, for instance, you often want to build interfaces, you want to build classes that you can extend from and everything. And this is good to a point. The difference between code that is executing versus code that is defining your infrastructure is code is both a execution medium and a communication medium. Code is not solely a method for developing or execution, right? Like if code were solely for execution, we would all write assembly language, right? But code is also about communication. And so I find that increasing levels of abstraction can make some of that communication component difficult for other engineers to consume your infrastructure, right? So the difference between code that is executing and code that is defining your infrastructure is that you can, the concept of dry, like don't repeat yourself, is a little less important. You don't have to manually, you don't have to provide an interface for every single possible component, right? You can be a little bit more repetitive in your code as long as it's readable and understandable. So how does this all shake out? If you look at the set of constructs that are available, they're broken down into a couple different levels. I talk about these constructs right now, but they're really a lot more. So it's beyond CI and CD and containers and serverless and application integration and other things now. Like you really have constructs for virtually every AWS service at this point. And we break the constructs down into a couple different levels. At the lowest level are the CloudFormation constructs. These are the L1 constructs that are direct mappings to CloudFormation resources. So when a new feature or resource or service is added to the CloudFormation spec, the CDK picks it up in their next release, which is they have a release pretty much weekly, not always weekly, but mostly weekly. And that CFN resource is now available to you in the CDK. Constructs at the next level, the CDK constructs, the level 2 stuff, these are handcrafted higher level abstractions for each AWS service, and they take care of a lot of the boilerplate for you. They generally contain sensible default values that let you get started quickly, and they enable a couple different interfaces that let you add permissions or add different integrations quickly. Not all AWS services have high-level abstractions yet, but the CDK team, service teams, the open source community, they're adding new ones all the time, and they're even improving existing ones. So, and this is something that our community can contribute to. And then one level up from those, you have pattern constructs. And this, to me, is the killer feature of CDK. This is the thing that finally sold me on it. Is I used to have to provision container clusters, right? And it would take hundreds and hundreds and hundreds of lines of CloudFormation. I would have to get my VPC import. I would have to get my subnets. I would have to get my security groups, all of this other stuff. Let's say I wanted to talk to SQS. I would have to have a VPC endpoint. And I understand the need for all of these things. I understand why we have these things, but it's still a huge pain in the butt to go and write it all out. And it's redundant, undifferentiated heavy lifting. What CDK does is it provides these higher level patterns, something like queue processing Fargate service. I am actually using queue processing Fargate service in a production AWS service right now. So in a service that some of you may have used, this queue processing Fargate service is literally 4 lines of CDK code are provisioning that across multiple regions. And in the past, building that same thing would have been such a huge undertaking. One thing that isn't spoken about in this presentation, but I want to call out now, is the concept of an aspect. So aspects are things that can be applied to different classes within a cloud or different applications or stacks or constructs within a CDK application, and they will do things. And you can think about it a lot like an interface. So let's say I apply an aspect called CloudWatch Alarms to an interface or to a construct. This could look at what the construct is, if it's S3 or if it's a DynamoDB table, and it could create the default set of alarms that I need for my application. I use an aspect right now on a service to build out a set of dashboards and a set of tags in a resource group. And different people have built out different kinds of tags and resources. So let's look at what this code looks like, right? This is the level 1 construct on the left. So right now I'm creating an S3 bucket that has an encryption in it, a KMS powered encryption. You can see on the left, I'm sitting here and I'm having to define the various actions. I'm having to construct this principal based on the AWS partition and account ID and apply this resource star, which is not always the right thing that I want to do. And then I'm having to create the bucket. I'm having to provide the server-side encryption. And if we look at the L2 construct on the right-hand side, I'm saying create my bucket in my stack with the name my bucket. This is just a logical identifier. And then apply this encryption. So this L2 construct is already doing the hard work of this redundant, undifferentiated, heavy lifting around building out my resource and IAM permissions and everything. And the other super, super, super important component to mention about CDK is that it allows me to follow the best practices of creating IAM policies with least privilege access, because the code is aware of the things that I'm calling. And when my infrastructure as code, or my infrastructure code, lives alongside my source code, I can automatically calculate and figure out exactly what IAM permissions I need and only provision those. So it's a very, very powerful change. This is the L3 construct. So this is building an application load balance Fargate service. This is taking a basic container image. And what's happening under the core is that I'm provisioning a VPC. I could also use an existing VPC if I wanted by providing a VPC from lookup. It's provisioning a subnet, an EIP, a NAT gateway, an internet gateway. And you know, some people don't want a NAT gateway for their VPC, right? They want the internet gateway and they want public IPs and things like that. These are simple options that you can override after this is created, right? I can assign this to a variable. I can assign this new patterns application load balancer to a variable, and then I can go .vpc, NAT gateways, and I can say, don't provision these. I just want to use public IPs. Don't do that though. And it sets up routes, it sets up route tables, security groups, ingress, egress. It provides a task definition. It creates a application load balancer listener, target group, target rules, IAM roles, IAM policies, log groups, configuration. And the reason all of these different things exist is that we're a community of builders, and we're trying to provide things that builders use, right? And I don't have a lot of time left, so I'm just going to go really, really fast here. But you can use these low-level constructs. When we first release a new service, it typically is a CloudFormation only. Then it goes into experimental. This is experimental phase. If you see the label experimental, that means the service can change before we release it. Then it goes into developer preview. These typically will not change. So once it's in dev preview, you probably will not see it changing. We have occasionally made backwards breaking changes for those things, but it's not common at all. And once it's stable, we don't make backwards breaking changes. So you can see in the documentation what this all looks like. Over here, you have resources. Over on the other side, you have constructs that are experimental. So this is the Elastic Kubernetes service. You can see that the level 2 constructs are experimental. I don't think they are experimental any longer. I think they're stable now, but the CFN resources are stable. And you'll see these labels throughout the kind of CDK. The roadmap is public. So you can go into the CDK GitHub repo and you can +1 and vote on different features. The roadmap has tickets for all of these different features. This is developed in the open. Customers contribute. We can iterate and improve at a much more rapid pace than we could if this were solely a private project. And we take RFCs. So right now, a really interesting and important RFC is continuous delivery for CDK applications. And this is something that our community can comment on and participate in. And I would encourage you to do so. I don't have enough time to give you an example, but I will post the example in the chat so people can go and play around with it. You, as community members, are welcome to contribute to the CDK. So I would encourage you to be a part of this. I think this is really the future of building infrastructure, and you'll see dramatic changes over the next 2 years in how infrastructure is delivered based on tools like CDK. So just to provide a quick summary, CDK lets you have these high-level abstractions for defining infrastructure as code. It leverages the power of CloudFormation to provision those underlying resources. And at its core, it's open source. So this is an open source community that is driving and building the future here. And if I can just go back to the very beginning of my presentation, I think this is probably the most powerful thing that I can say today. We're all having a rough time right now. I know many of you are in communities that have been hit hard by COVID. I know many of you are in communities that have had to protest for basic human rights recently. And I'm really, really proud of these communities for fostering an inclusive and powerful culture. Please, please, please maintain the highest standards, maintain the code of conduct, maintain your diverse and powerful communities, and help bring as many people into this as you can. Thank you all so much for listening to me rant and rave about CDK today. I hope you have a great rest of your day watching these presentations, and thank you to the organizers for inviting me.